Okay, so welcome again for this session. We are going to summarize about the session which we are going to discuss in today's session. Let's begin with the first agenda. We have Matplotlib library in the Python, right? This is the agenda for today's session. And let me write it down like heading is Matplotlib in Python, right? And then we are going to write the respective import library. So first and foremost, I'm going to import matplotlib. So mat is like what? Mat is mathematics, right? We are going to perform the mathematics library there, right? Then we have plot. We are going to plot some library there, right? Then we have library for the same. So then py stands for Python, and plot, we are going to plot these library, and I'm going to rename it as a plt. Why? Because we don't need to write this entire this giant kind of name again and again. So I'm going to alias this entire name from matplotlib.pyplot to plt. So this is the synonyms name. This is the synonyms name for my entire name, right? So I'm going to import this one. Just wait a minute. So along with this library, I'm going to import another thing which is called import matplotlib.mlab. This is the another library I'm going to import, and this is the library name like mlab. Its alias name is mlab. The third library I'm going to import in my session is numpy, number in Python. Short, this is called numpy, numbers in Python. And the again synonyms for this library is np only. Let me run this code one very first time. Now I am having all these library in my Jupyter notebook, right? Now I am going to import plt.plot. This is the plot function, and then I'm going to write 1 comma 2 comma 3 here. This is the first list number, and the second list number is, let's say, 3 comma 4 comma 5 comma 6, right? So let me write one more column here, like let's say 4. So 4 at the x-axis, 4 at the y-axis, and these two are different values, right? Can you see? It's showing the entire graph. Just plt.plot is showing entire graph, right? If you create something, another relationship like 13, 4, 5, 6. So can you see this 13 is showing respect to 1. This is showing 13. For the 2, it's showing 4. So for 2, respective value is 4. For 3, respective value is 5. And then for the last 4, it's showing 6. Right? But I need to add more features here. More labels, some external values. So I'll write �xLABEL label. For my horizontal label, I'll write, let's say, sales values. Right? So this is the sales value. Then plt.y label. Then I'm going to write, let's say, profit. For my sales, what is the profit value there, right? So this would be ease for my graph representation, right? For my anyone can see this graph representation looking at the x-axis and the y-axis, right? So this quick overview of this graph is just rotating about x label and y label, and let me write plt dot show eventually. So can you see this y label is profit values and this x label is consisting sales values. Now you can clearly say these x level values are representing sales, whereas profit showing at the y axis, right? All the profits are showing using y axis, right? But sometimes we need to add elements to my line plots, right? For this, what I'll do, I'll write t is equal to a single variable, and this is going to take from numpy np.arrange, or this arrange function will consist some o.o, then 2.0. So let me print this t here. Can you see? This is just entire range number. Only two value, like it's divided 0 to 2, only one value. Instead of two value, if you write 10.0, so can you see it's dividing all the range 0 to 10 with the 10 numbers 0 to 9, right? Which is the division part integer wise. So generally equally spaced numbers between 0 and 10. Now let's see, I'm taking very small range, that is 2.0, but this range I want to divide based upon 0.01. Of course this would be large number. You can see it's a scattered around two lower number and the higher number, 0.0 and 2.0. So you can see on this slide we have so many numbers lying between 1.9 and lower value is 0.0, 0.0, right? For this, I need to calculate some sign function to the random values. So what I'll do, I'll write another variables s is equal to 1 plus np dot sin. This is the sine theta and cos theta, what we have studied in the trigonometric in 10th class or 12th class, right? So first point of discussion is, why do we sign function? Because we want to deploy all the range value, all the deployed value. You can see here in the matrix, all these value I want to deploy over the sign function. So I'll write 2 multiply with np dot py multiply with t, which we have just created above. So this is going to apply sign function to my random numbers, right? And let me write this np.py. What is the value of this? Can you see? This is nothing actually pi value. So in how to represent pi value in the Python, we have predefined constant value that is taken from numpy, and numpy is given as a alias np. Now in a real life example, how this plays out, this just write np.py, you will get pi pi value, that is 22 upon 7. Instead of this value, if you write 22 by 7, you will get the same value. So I'll write np.py. You can compare both these values are almost same, right? Let me remove this one, this also. Now coming back to our code. So this 2 np.py, this is the numpy value 22 upon 7 value. Actually what is there, actually we will have to write 2 pi r. So most of the times you have seen in the parametrical area, or in the circle area, we have potential solutions for to this problem using 2 pi r. So 2 pi r, but how to write pi in the code? We have to write np.py. How to write r value there? We have t, we have representation t for the same. So for this 2 pi r, eventually we have converted to this 2 np.py t. Is this correct? Now let me run this out. Right now, finally, I want to create a plot, plt dot plot, in between t and s. So I'll write t at the x-axis, s at the y-axis. You will have the same position. Can you see? This sine curve is just shown on the screen, right? And if you focus at the x level, it's rotating around 0 to 2.00 only, nothing else, right? So here is an example of what we are talking about, a sine curve using Matplotlib. Instead of sine curve, if you want to create cos curve instead, so you can write cos instead of sine. If you, oh, okay, then I'll have to write plt dot plot and t versus s. if you can see, this is just reciprocal, and the graph is starting from the upper part only. It's the inverse of this curve. So there is a clear trend here. You want to create the respective graph. Now, inside the plt dot plot, I want to add some features. What is the feature? If you focus at the y-axis, I don't have label there. If you focus at the x-axis, we don't have focus like voltage, time in seconds, or get value, right? Some background on this issue. So what I'll do, I'll write plt dot x label, and within the x label, I'll write time and write s here, and will create some y label, and then voltage in the microvolt, right? Then I'll write plt dot title. With this title, I write about the electrical engine. This is the electrical engine value, and now I need to print plt dot grid. I want to add some grid here. This should be true, and we will focus this tree. What is the grid value there? Let me create this file also. Then finally, I want to create plt dot save figure with the name test dot png. This graph will be saved by name test dot png. I'll have to save my local direction machine, and I'll check my directory there. And finally, I'll have to show this graph using plt dot show. Let me run this out. Matplotlib no high level. Oh, LAL. Can you see? This grid is kind of electrical. Can you see this grid? Okay. So we have graph plt dot show. We have x label versus time in second. We have y label in voltage in micro voltage, right? And then we have title of this graph about the electrical engine, and then grid is equal to true. Can you see? From the as compared to previous graph, we didn't have any grid value or the matrix point there, and particularly pressing issue because we need some initial point. Can you see this graph is starting from this value, and it's going to end some grid position corner there inside the grid. So this is the benefit of my grid value. If you want to keep it false, so by default it is false, but if you want to keep it false, can you see now grid is not showing on my graph. So let me clarify this point further. If you need some zoom in value or some kind of application part where your graph is starting, or what is the trend of your graph, you need to make it true, else you can make it false, or rather not to write it here, right? So this is the particular aspect of my graph, right? This is the grid value there. Now going for the next graph, I'll call it bar chart, right? So bar chart will be shown by some intelligent value or some aspect data visualization part. Okay, coming back to the bar chart here, some we have to initialize some value. Let's say I'm going to create this y with some random value 3, 7, 5, 4.5, 6, 8.1, right? Then we have x is equal to range. Within the range, I'm going to write this range a length of y, right? What is the range? So let me print y first. Yes, this is the giving exact value. Now let me print x value. Can you see? This is showing 0, 7. right? This is just upper value of my range or kind of starting and ending point, right? So we will see how this will be impacting in my bar plot. Let me have this width is equal to 1 upon 1.5. This would be width of my graph, right? Column itself, and the width of my each column, and then plt dot bar. Within the bar, I'll have x comma y comma width. What would be the width, right? So this would be the width value, and let me have what would be the color of my chart. So let me keep it blue here. And finally, plt dot show. So here is the respective bar chart. You can see it's showing all the graphs like 0 to 6. What is the range here? 0 to 6 length. And for the 3, it's showing 3 here. For 10, it's showing the second bar height is 10. 7, we have third bar chart 7. And for the last, can you see this is 8.1? If you focus or compare this last bar height, it will be around 8.1 exactly. Now coming back to the range, we have range value for the x itself. Now coming back to the width itself, right? Suppose I'm going to create 2. So of course this would decrease the weight of my column. So 1 upon 1.5 is higher than 1 upon 2, right? So now my bars will be squeezed sometime. Can you see? Now they are more thinner. If I'll write 1 upon, let's say, 3. Can you see? They are not more thinner now. If I write 1 upon 4, this thing, they are now more thinner as compared to previous one, right? So you will have to break down this entire graph, this entire code. What is the responsibility of each line, each command? You must know how width is playing role in your bar chart. If you'll write 5 over here, can you see this is no more width? Can I make it 1 upon 15? Yes, of course. Now my bar charts are here kind of fine thin sheets, right? So it depends upon your case study. What is the part of this one? So we have seen what's the impact of this width here, but we have other features also. Like what are the features? These are plt dot bar. So first we have seen this is uh, xy and width and color. Let me change this color from blue to red here. So you can see these bars are now converted into the red color, right? So this is the impact of my entire value that we have another color value for the same, right? Can I have another value? Let's say yellow. Yes, I can have yellow value also, right? So suppose let me change this width again. What was the 1.5 and color yellow? Yes. So can I have green? So many others options are also available, right? Right. So this is the feature of my graph value, right? Okay. So now can I generate numbers or can generate the bubble chart? Okay. So the next we create next heading. This is for bubble chart, right? So we can create bubble chart also. Like in my company, I need to create on the basis of frequency, right? So what I'll do, I'll write n is equal to 50. This is the number of charts I need to create for generating random numbers, right? This will be used for generating random numbers. So first I'll create x value. This is np dot random. and then I'll use rend function here. Along with this rend, how many numbers I want to rend, I want to create. So n 50 numbers. So rather than writing 50 again and again, I had declared at the very first line n is equal to 50. And in the realistic problem, you will needing some y-axis also. So np dot random dot rend function again, and how many numbers do I need to generate? 50. So I'll write n here again. Now let me write colors. So what is the colors here? So colors is equal to np dot random dot rend function here, and again how many colors do I need? 50. So instead of writing 50 again, I am writing capital N. So let me write area. So what would be the area for my bubbles? So that this will depend upon numpy area and then 15, and then np dot random function dot rend function, and along with this I'm going to write np, right? And this should be power of 2, right? So 0 to 15 point radii, I'll write all these numbers, right? So this will be area for my scatter plot. Now I'll write plt dot scatter. This would be the predefined function, and then x comma y, first two random numbers, and then what would be the area? So area will be, S would be area for my bubbles. So C is the colors. So if you need colors here, so I'll write colors definition over here, and then alpha, I'll explain alpha one more time. So let me write 0.5 as of now, but I'll show what is the impact of this alpha, how this value is going to impact in my graph there. So let me show this graph one more time, and lt dot show, and you can see the scatter plot on the screen. So this is depicting different colors here. Okay, let me come one more time. N is equal to 50 is constant value to generate different size value. X is the first horizontal value, and Y is the vertical value for my generating value in between 0 to 1, right? So this will generate different n values here, 50 values here. As far as colors will concerned, so I'm going to colors np dot random for the different numbers, right? And now 15 multiply by random number multiply power 2. So this would be area for my bubbles itself, right? And now coming back to the scatter plot, for this x and y, first two arguments are my values, horizontal and vertical respectively. S is stand for plot. Okay, let me write plt dot scatter here. If you write alt or some control value, or if you hover around the keywords, it will show the respective, some kind of respective functions. Or if you write, let's say, help scatter, so you will find help plt dot scatter. Okay, so there might be some other code for this helping, yeah, but we can check the particular definition for the same, right? So we have alpha is equal to 0.5. Suppose you will write 0.1. Can you see they are more lighter now? This is the transparency of my bubbles. This factor is for increasing or decreasing the transparency of my bubbles. If you write highest value, that is 1, but let me write 0.8 here. Can you see the bubbles are now darker? If you write 0.9 here instead of least value, so you can see now they have less transparency. If you write 1, which is the maximum value of alpha, can you see they don't have any kind of transparency? They are overlapped each other, right? So why do we need this transparency in this scatter? Because sometimes what happens inside the bigger bubbles, some small bubbles may be hidden. So in order to depict these hidden, let me write 0.5 here. Can you see inside this big bubble, if you zoom in out, this these two bubbles are hidden, right? We cannot see these two bubble if we'll make it 0.8 or 1 itself. That is the highest value of alpha, or no transparency for my bubble. Similarly, if you check these two some numbers here, some small bubble is hidden behind these three bigger bubbles there, right? So bigger fishes are hiding small fishes in my screen. So let me write some another graph with one transparency which is highest. Now can you see, if you at the first glance you see the numbers are hidden within the higher block. So that's the wrong accuracy for my plotting graph, right? Now going for the next part, we can have the pie chart, right? So which is mostly used for the different aspect. If you go for the Google and look at the pie chart in the news, you will find so many realistic example there, like we use for population, BYJU's are using mathematics, science, English, Hindi. Sometimes we need for Williams, their names, countries ratio, Canada, UK, and number of participations per game, Monopoly, chess, poker, So we can see so many mathematics, French. In universities also we are using favorite subject. Recommended diet also, fruit, protein, grains. So pie chart is used in different case studies. So let me create pie chart, right? Where where slice will be ordered and plotted counter clockwise. I explain what is this slice and what is the ordered, what is the counterclockwise. One by one, I'll explore all these technical terms, and I'll illustrate one by one using my pie chart depiction here. So let me write one first and foremost. What would be the labels? So labels would be, let's say, going to treat first is frogs, right? Second labels I'm going to take hawks. Third label I'm going to take, let's say, ducks, right? Third label I'm going to take that like hawk, right? And so on. So respectively, what would be the sizes there? So let me give 15, comma 30, comma 45, comma 10, right? So what's the significance value for this size? If you write down these sizes here and give some summation part or the addition part for these values, can you see this sum up 100? So you must keep it. This is important note that you must underline that the sizes all summation will be 100 every time, right? Otherwise there would be blank space in your pie chart, right? Now I'm going to write explode 1. Explode is for O, comma 0.1, comma O and 0 again. So only explode the second slide here, that is for hogs, right? This will be coming out from my session, coming out from my graph. Can you see here we have three explodes, blue, purple and blue. So for this three output graph we are to write this graph. Can you see here we have adults portion coming out of my pie chart. So this is called explode. So which portion of which category you want to explode from your chart, that's the key point here. That's the objective of my portion. Can you see? Yes, 10% is coming out of my circle, which is the explode part of my category. So no is 90%, 10 is 20%, Hence, I'm going to explode this out for my visualization, right? Let me write figure 1, comma, axis 1 is equal to PLT dot subplots, and within the subplots, going to write AX1 dot IE, and then sizes, and going to explode equal to explode. This will be coming out from my value. Going to write labels equal to labels variable again, and auto t. So this would be the value for my fraction point. So 1.5 f percentage value, and then finally I'll need to create some shadow. For this it should be true. I want some shadow for my graph. Then start angle would be 90 degrees, and I explain all these technical terms once again. Axis 1 dot axis will be equal, right? Finally, this with equal aspect ratio shows that pi is drawn as a circle, right? Finally, I'll write plt dot show float is not defined. Okay, 𝑥plode. Oh, sorry. Float is equal to axis 1 x1 axis float is equal to error here complete form. Okay, you can see graph, but it's not complete. So we have labels is equal to labels, auto piece equal to O percent. Yes, now I am having all my complete pie chart. Now, going back to the starting point, how this pie chart is going to create. First, I created the labels for my frogs, cocks, ducks, hawks. You can see on the screen. Size, they're 15%, 30%, 45%, 10%. So you can see the highest portion is for ducks, and we can see 45% is for ducks, right? This crystal clear, represented by green. Now explode. So 0.5. So let me increase this value. Let's say this is 0.3. Let me run this code. Can you see this is coming out, but the how much distance it is coming out from the original location. So now it is farther more away. Let me change it 0.5. Now can you see this is more coming out from my pie chart. 0.8. So of course this will be farther away from my actual value. So let me keep it 0.1 one more time. Now we can see figure axis1 PLT subplots for the subplots only, and for sizes explodes labels. Okay. Now we have this 1.1, which is the fraction ratio for these 15-10 point ratio. If I write 1.3 and look at the fraction portion here, you will find the impact of this value. Can you see? The value after the decimal are now increased. So after the 3 positions or the three values, it will show on the screen. You need that kind of precision, right? Post decimal value. So this is for that purpose we need pictorial or the point value. So 1.13 value, right? Now let me keep it shadow is equal to false. Can you see the shadow below this piece of cake? So if I make it shadow equal to false and cut A, cut C, and make draw it again one more time, can you see now I don't have any shadow below my pieces. So this pizza slices, kind of pizza slices, are not having any shadow below these parts, below these colors, right? So this is the impact of my shadow is equal to true. Now coming back to start angle, 90 degree. In case you want to rotate this entire circle, what I'll do, I'll write start angle is equal to, let's say, 180. Can you see this entire angle or entire this one? Can you see the difference between these? This one is this one. This entire pizza is just rotated 180 degree. All right. So this red color is just here 180 degree rotated, right? If you write instead of 180 degree, if you want to rotate 270 degree, you can write it. Can you see? Can you visualize the 270 degree rotation for my entire pie chart? This is the start angle for my angle value. Sometimes we need this coming out, this exploding part at the top. So what do, I'll rotate minus 90 degree and let me check it out whether my realistic requirement is fulfilled or not. No, it's not that much. Can I go minus 40 degree? Yes, it is something there. Can I make it minus 40 degree? Yes, it's coming out, coming at the top. So can I make it 35? Yes, it's coming at the top. So you can rotate the entire circle using this as start angle. So you can explode, can make a top value if you want to keep these ducks at the top level. So you can rotate as per your need, your realistic example, right? This is the area, or this is the pie chart, or here you can see you can create the entire value also, right? This is the all about my pie chart value. Let me recap one more time what we have studied so far. In the Matplotlib Python, we have just imported all the libraries and then just created the simple plot linear graph here, which is using this plot library, X label and Y label. Finally, we use this np.arrange. Here we have this arrange value 4.2 and with some range 0.01. We just partition into different sections, right? Finally, we just created the grid value and the save value. If you check out the save point, you will find this test.png. Let me check it out in my home page. If you can you see this test.png is here. If I'll download in my local machine and open in my local PC, it will look like this original JPG image. You can you can paste it in your Word file. You can paste in your PPT. You can deploy in your some other files also, right? So this is the impact of my entire this area, right? So if I go to the bottom, we have bar chart here, we have bubble chart here. So bubble chart is just showing with the respective transparency, and we have different non-transparency also there. Pie chart with the exploding part with the friction potential, and we have different labels. Now I'm going to create this T part which I just copied from official Matplotlib library. Let me run this code. Can you see this is showing 3D graph, 3D scatter plot. But how it is running? Can you see x-axis there? Can you see y-axis? Can you see z-axis? Right? So on the basis of these three axes, we can create multiple graph over the projection part. Right? If I keep on rotating different 3D surfaces, let's say 3D surface, if I copy this code and go back to my Twitter notebook, paste it here, but we must understand what is the style.use. We are going to create that platform here. What is the sqrt? This is the function for my relationship, right? Let me run this code first. Can you see? This is the 3D graph for my entire x tick level is there, y tip level and projection value, y minimum value, what is the effective y minimum value, right? So this is the plot for my entire rotation.